Oh yeah, no, it's time to go. I have my slides. Oh, you want me to? Yeah, if you don't mind. Just do this way. Or should I say next? Actually, can I just say next here? Sure. No. No. I mean, this is going to be an issue for a lot of people. This is not for Untitled, right? This is not I'm not sure. Okay, you can do it. Okay, all right. Pardon me? Sure. I don't know if you want to plug this in, but yeah. I don't know if that. Yeah, I don't know if that works or not. All right, folks. Welcome to CFRG. Please take your seats so we can get started. I think I'm you. Yeah. Live steganographic stuff on the screen there. It says Alexa. So I said it doesn't matter. It's fine. All right, folks. Welcome to the first of 2 CFRG sessions. That's right. We've gotten that popular that we have 2 sessions. Lots of work to get through today. So let me just go through these chair slides. Next. Okay, reminder, this is being recorded. We have Scott as our minute taker. Thank you so much again. Scott's a hero of this group. Jabber comment relay. This is all incorporated into Meet Echo, so this is fine. All right, this is the note well. This was updated last time, and please take a look. The IETF has similar constraints as the IETF, and if you have any IPR, you please disclose it. Yes, and this is meetings being recorded and streamed, and if you don't know that, now you do. It's Monday. Okay, we also have a code of conduct at the IETF, which is relatively new, RFC 9775. So if you are going to be participating in this group, please take a read and understand where the bounds are of conduct within this group that we expect of folks. All right, I'll brush through this real quick. This is an IETF group, meaning that it's a research group. It's focused on long-term research issues. Most of the goal of what the CFRG does is to help clarify and provide advice to groups who are using cryptographic primitives in protocols, whether for security, for privacy, for other things. And so the output of CFRG is documents that are meant to be as helpful as possible for people building products in the IETF and outside. All right, we have a packed agenda. Today's we're going to mostly be talking about adopted drafts and current statuses and how to move them forward today, as well as we'll have one new presentation. And then tomorrow we'll be, for the most part, sorry, not tomorrow, Thursday, the second session, which is at 5 p.m. We will be seeing, for the most part, new presentations, although some we'll have some pretty detailed discussions about the hybrid chems, which is an active field of conversation. All right, we'll blow right through this real quick because we have so much to get to. But document status, we have 3 new RFCs since July. So congratulations to Hashbakes, Signatures, Kangaroo 12, and Opaque for making it through. We can clap, why not? We also have 2 in IRSG review, as well as 2 in research group last call, which the chairs will comment on the list. Next slide. All right, newly adopted drafts. We are going to be talking about these in the second session. Fiat Shamir, interactive Sigma proofs. This is the start of the CFRG looking at zero knowledge and helping provide some shape and some advice to folks who are looking to use those primitives and those capabilities in their drafts. Active drafts, we have a ton. So most of these have been updated. The last 2 here we'll hear a quick update from. It says unchanged, but there'll be a new version within the next, within this week. Next page. And yeah, these are the remaining expired adopted drafts. So hopefully some of these will be brought back into the fold, and we'll be discussing that today. All right, just quick update on errata. Since last time, there's been 4 new reported errata, as well as, well, 5 new, and 2 have been closed. So if folks want to help close these erratas or take a look, the mailing list is open to anybody who has comments on whether they're verifiable or rejectable. Next slide. All right, this is just a quick reminder that we had an interim meeting to talk about hybrid chems in between last meeting and now. This was well attended. We had 29 attendees, and there's been follow-ups on the list. And today and Thursday's meeting, today we're not going to talk about this so much, but yeah, on Thursday we will. And for the group, if anybody has feedback on the interim meeting, we're happy to hear it from the chairs. If this is something we may want to repeat for other thematic grouped documents like these 2. All right, and agenda bashing for anybody. I see that we have folks in the queue. Yeah. Okay, well, open it up to the queue, and then we'll hand it off to the first presentation. So. That's you, Mike, I believe.
Is it cue me? Mike Ellsworth. Yeah, slight bash. You blew through the Jabber Zulip monitor role, and there's been some discussion on the chairs list. I just want to, like, CFRG tends to have a very active Zulip chat.
Yes.
If there's something in the chat that you think is important for someone to say at the microphone, please tag that.
In the chat.
Stuff goes in the chat that maybe people in the room aren't watching but should be aware of. So just tag please repeat at mic or something like that. Thank you.
Okay, yeah, thank you. Yeah, and that's a reminder, active Jabber room, some of these things are worth saying at the mic rather than in the room. All right, so we're kicking off the first presentation, which is Christopher Patton. We are, yeah. This isn't working. Cool.
Okay, this is an update on verifiable distributed aggregation functions, or VDAFs. Next slide. So it's been a while since we talked about this draft. It was adopted back in 2022. Just to remind folks of the problem, the tech industry, all of you people, collect way more data than we need to about users. But this is a solvable problem. The goal of secure aggregation is to take your measurements, do some computation on them, spit out an aggregate without ever seeing measurements in the clear. Next slide. So to solve this problem, we formed a working group in 2022 called PPM, Privacy Preserving Measurement. And these are our motivating use cases at the time. Browser telemetry, COVID-19 contact tracing was a big one back then, as folks might remember. And then, of course, ad tech. The W3C has a working group that is basically, in part, deploying things based on the protocol that we're developing in PPM. And then more recently, people have been thinking about how to use the framework for federated machine learning, where you want to train a model, but you don't want the data to leave client devices. So we have one big draft called DAP, which kind of defines execution of a VDAP over HTTP. So this is kind of the core protocol. And then we have one extension that's been adopted by the group, which adds some nice security properties. And then we have a variant of Prio, which is sort of for a specific PAT-WG use case. And then we have a long tail of dead drafts that, where people have proposed either different ways of doing things or adding different security properties to DApp. Next slide, please. So the goals for CFRG was to, first of all, define a framework for solutions in this space. All are based on a kind of lightweight form of multi-party computation. And this is what we call a VDAF, a protocol that fits into this framework. And there were two concrete VDAFs that at the time, contemporary, that we wanted to fully specify. One being Prio. This has been around for a long time. It's a way of doing general purpose metrics for lots of different use cases. And then Poplar, which is a little fancier, and solves a particular problem we call heavy hitters, where you want to know the set of measurements that were uploaded most frequently. And this is a sort of interesting nonlinear computation that doesn't fit into Prio. Next slide. And then our other third goal, which should be the goal of everyone at CFRG, is to engage with the research community on things of interest to IETF. And on this front, we had some moderate success. We had some work on the specifications themselves. We've also had a couple of new VDAFs be designed for new use cases. And there's also been, there's a lot of great researchers developing new techniques that fit into this space. Next slide. So just to kind of explain how these things work. So the simplest thing you might want to do is each measurement is just a vector of numbers, and you just want to add up these vectors element-wise. Next slide. And the way we do this is with additive secret sharing. So I'm going to split my measurement into two vectors, such that if I only have one of these vectors, I can't discern any useful information about the underlying measurement. In fact, no information. It's information theoretical. And I upload those to two servers. The servers locally aggregate, and they spit out their secret share of the aggregate result. Next slide. Now the problem here is that if I'm just consuming random looking numbers, I can't distinguish these from valid measurements from invalid ones. And the way that we solve this is a client generates a zero knowledge proof, a special kind of zero knowledge proof we call a fully linear proof in the spec. That the servers interactively check before they consume the measurement. Next slide. So Prio is essentially just additive secret sharing plus this FLP for verification. Not much more than that. Now, heavy hitters, basically this boils down to aggregating big, long, one-hot vectors. So each client has a vector of a bunch of zeros, and then in one of these positions, we'll have a non-zero number. Next slide. So Prio is not super well suited for this if the vector is very big, because the communication cost is linear in the size of this vector. The solution to this is something called a distributed point function, which basically provides a way of concisely representing this information in a secret shared manner. Next slide. And Poplar is essentially just this DPF that we use for privacy, and then a technique called arithmetic sketching, which was generalized in a crypto paper later on. And I'm not going to say much about this besides this is just a particular kind of lightweight multi-party computation. Next slide. So we've been developing this draft for quite some time. We've gotten a lot of feedback from a lot of different people, from implementers, from researchers who have pointed out either bugs like security issues that we've been able to resolve, or find ways of improving things, like replace TurboShake with AES here, like is a safe thing to do and speeds things up, that sort of thing. And also of course from PPM and making sure that this fits into the DApp draft and is actually useful for it, and also other things, other protocols you might want to build around this framework. And in fact, we went through crypto panel review earlier this year. So that's where we are now. We've incorporated all feedback that we've heard, and we should be next slide. The next step would be research group last call. But next slide, I'm going to talk about two issues that remain. These are both breaking changes, so I want to make sure we carefully consider these before adopting them. The first is that we can improve the way we do range proofs. So in the zero knowledge proof system, we have a circuit that defines a range proof that basically checks that a number is in a range that we expect. This is really cheap to do if you have a range that's a power of 2. The way we do it for non-powers of 2 ranges is more expensive in terms of communication costs. And this actually prevents us from using it in all of the PRIO variants that we have. We would like to be fully general, but we can't without like blowing up communication cost. But there was some discussion on the Fiat Shamir and Sigma protocols draft that made us realize, oh yeah, we can actually do the same thing that they're doing there in this protocol. So it's a pretty simple and simple change that gets us to sort of arbitrary range checks for the same cost as a power of 2 range check. And there's a PR up for this. What it does is it aligns all range proofs in the spec on this one thing, which means it's breaking for all of these variants. And there's not much more change in communication costs because we were not, we were just being less general than we were before. But the result is that SumVec in particular is a lot more useful because each of your vectors, elements in this vector, can have an arbitrary range. An alternative would be to just change SumVec and leave the other ones alone, but we would like to avoid having multiple types of range proof in the same spec. So that's one change we want to consider. Just to summarize, this is just being smarter about how we describe these circuits and gets us more functionality. Next slide. The more interesting one is this really cool paper from my colleague Armando Faz, who I think a lot of you know. He basically he observed that, so we have this polynomial that we store in the proof, and this is used to simulate multiplication gates in the circuit that you're evaluating. And we just simulate that by evaluating this polynomial. And we represent it in the monomial basis, basically what you think of like from elementary school. What he observed is if you represent it in the Lagrange basis instead, basically after doing an NTT operation, things get way more efficient. You don't have to do as much computation. The problem is we need to evaluate this polynomial. And so you would need to do it in the Lagrange basis, which is more expensive using naive techniques. Armando wrote a paper where he basically found another way to do it. It involves some clever math tricks, but it makes things way, way, way faster. So this is pretty conservative numbers. At least a 50% speed up for proof time. It's even better for verification time. Yeah, so I'm not. That's all I'm going to say about it. Armando's going to talk about it more on Thursday. But yes. So next slide. The question for you all to help us settle is, do we wait to cut one more draft before and take both of these changes? Do we take one or the other? I think our perspective as editors is it would be a shame to leave these improvements on the table. But of course, like cryptography is going to keep advancing and we can't wait around forever. This draft has been around for a long time. It has a small but enthusiastic group of adopters. They have signaled that they're willing to delay last call to take these changes. But the other observation is that we've done crypto review panel. I don't know if we'd have to do that again, but yeah. Anyway, what do you guys think? That's it. Yeah, they changed the schedule, I think. Oh, great. Yeah, Armando's coming right up. So, hold on to your hats.
Tim?
Thank you. Tim Gagan, Internet Security Research Group. Okay, I have a few comments. Let's see. First off, I think we should take in VDAF the changes you just discussed. The performance wins are big, like really significant for real workloads that we're currently running. So this stuff is worth it. Okay, next. You were asking like, where's the cutoff point, right? Like, I would say once we take those changes, we should, sorry, I'm not certain what the CFRG process is, but like go back to RGLC or whatever the next step is. Because even if some hot new paper comes screaming in like the day after, the nice thing about VDAF is it's a framework, right? So we can define new variants that is like, it's pre-03 plus, this cool new thing. Then people can go implement it. We can choose a code point for it, and we can go deploy it, right? So that doesn't, trying to get VDAF to RFC does not preclude the development or deployment of, these further optimizations that may emerge. All right. And then last thing I would observe is in that same theme, I would like to urge the research group to like move this along to back to crypto panel, to RGLC, whatever it is. We're running this stuff in production already, servicing significant workloads. It's out there and it works. And this document, I think, is ready to move along.
So do you think, I guess you guys should decide if we do take these changes, should we do crypto review panel again? What would you want to do?
So I think in this case, you have a relationship with a crypto panel reviewer, and we can reach out to them to see if they're willing to review the diff.
Okay, cool. All right, I think that's what we're going to do then, unless anybody has a different opinion. Okay, I'm going to ask Julia to if she's down to review the diff, and we're going to make the changes, and we'll cut one more draft. Thanks, everybody.
Thanks. And Armando? Armando, going once, going twice. We might have to skip ahead to the next one.
Yep, got a message from Armando. He won't be able to join for this session.
Okay. Let's skip ahead to the next one.
So hello, do you hear me?
Yeah, we can hear you.
Perfect. So I'd like to summarize the status of the CPACE draft. So essentially, the CPACE draft hasn't seen any significant change since last year. So the slides I'll be showing today are essentially the same which I've shown in Dublin. And we like to ask the chairs for issuing the research group last call in case that there's no issue communicated by the audience. We are not aware of any significant change or change request. So the change, maybe next slide, I'm reporting on all of those in the next slides. So what has changed since the crypto review panel reviews? We have included all the feedbacks. We essentially, the biggest change was that we have removed the reference to the network representation, which was a suggestion by Thomas Purna. We had added a guidance section regarding how to best integrate CPACE in higher level protocols. We added the new results of the BEAR-PAIC papers from last year, which covers, independently covers now the issue, the topic of the session ID that can be calculated alongside with CPACE if no session ID was available before starting CPACE, and which also analyzes the UC security of CPACE without a pre-shared session ID. And we have now human readable and embedded JSON test vectors, and we added the link to the reference implementation that we used for generating the test vectors. Next slide, please. So we'd like to thank very much the crypto review panel reviewers, and that has been very, very valuable and helpful for us. As a type of a change log, we have noted all the different aspects with responses from our sides and how we address the issues which have been brought up. in this to-do review document file, which we had as a changelog, which is hosted on the GitHub page where we host the CPACE draft. Next slide, please. So regarding the security analysis, we now have added the reference to the BERPAC paper from Manuel Barbosa, Gellert, Julia Hesse, and Stanislav Jarecki. And the results of this paper were that CPACE now is also proven UC secure, even if we don't have a pre-shared, pre-established session ID available before starting with the protocol. And this confirms the complements the game-based security analysis, which we already had in the CPACE paper from 21. So we now have 2 independent studies confirming that CPACE is specified in the draft is secure also without a preceding message flow. This also resolves the main aspect brought up by Kartik. Next slide. So when looking what has been done since the PEG selection process, when writing the draft, we have been focusing on the target reader group of protocol implementers, testers, and integrators. And we have this paper series, and specifically the CPACE paper from 21 at AsiaCrypt, which provides a one-to-one correspondence between the cipher switch we suggest in the draft and the security analysis. So it's really a one-to-one correspondence between the draft and the paper, so which helped us to focus more on implementers, and we referred the security analysis and researchers to the paper. So, and we kept notation and concepts together so that you have the one-to-one correspondence. We have integrated the insights of the BERPAC paper and collected all the feedback from implementers and during CFRG sessions regarding the cipher suites. We had the crypto review panel reviews and incorporated the changes in the draft. We have the reference implementation, and we think we have collected and integrated all feedback that has been available to us on the list and off the list. Next slide. So to summarize, we think we have a stable draft which is ready for proceeding, and we would like to ask the audience if there are any remaining concerns, and if not, we would like to ask the chairs to start over with a research group last call right after IETF 124. So, thanks.
Any other concerns? Anybody have questions about CPACE? Winner of the competition? No? Okay. This seems reasonable to us. We'll confirm with you and go forward.
Fine, thanks.
All right, Yumi. The next 2 presentations are going to be about drafts that have expired, but the authors are getting back together to revive them. And there's an entire stack of dependencies, and the pairing friendly curves draft is the bottom of that stack.
Okay.
Yumi?
Okay. Hello, everyone. I'm Yumi Sakemi from GMO Connect Japan. Today, I will talk about our draft pairing-friendly curves. This work started several years ago And we plan to restart our work for IETF 124. And next slide, please. First, I will introduce pairing and history of our draft. Pairings are used to realize advanced cryptographic primitives such as BLS.
John, could you please turn off your video? Thank you.
Thank you. Okay, I start. Yeah, such as BLS signatures, ZK snarks, and identity-based encryption, and so on. The security depends critically on the chosen pairing-friendly curves and parameters. So in our draft, we proposed the recommended parameters, and they were passed expert crypt panel review, and our draft become RG item, and 2 RG Rust cores started in 2021. But now, unfortunately, our activity stopped later. Next, please. This slide shows the problem and goal in our draft. Problem is that Kim et al. Proposed the attack for against pairing-friendly curves in Crypt 2016 named EXTNFS, and the attack reduced security level of curves like BN to 54. But yet, legacy pairing parameters are still in use even though their security is no longer strong enough. So we'd like to provide a clear, practical list of pairing-friendly curves and parameters with post-Kim's attack security levels. Next slide, please. And this slide shows why the draft status got stuck. First, I want to make it clear that the pairing parameters are not cores, and those had broad consensus. The main cause is disagreement on scope of this document. In detail, we would like to focus on standardizing parameters, but on the other hand, the reviewers want textbook level tutorial explaining the full background of pairings. As a result, because of this difference, we could not find a good agreement with the reviewers. In our current opinion, we believe a full tutorial belongs in a separate document, not in this parameter-focused IDE, because we believe detailed explanations of pairing algorithms involve many implementation choices. For example, how to define finite fields or extension fields, or which pairing algorithm to use, and they are not standardized in CFRG. So these topics should be discussed in a separate standardization effort. Next, please. Okay, now we would like to restart this work because our draft is bottleneck for other drafts such as BBS signature scheme. As proposed scope, we would like to focus on only the essential information for standardizing pairing parameters, aiming for an early RFC publication. But if CFRG members want textbook level writing of pairing, it requires a large effort. So we need volunteers, and please help us. Next steps are shown like this, and especially feedback from implementers, protocol designers on what information is most useful. So please feedback through CFRG mail list or talk to us after this CFRG session. Next, please. Please skip. That's all. Thank you for your attention.
Oh, question from Rich. Go for it, Rich.
Yeah, sure. I just want to say thanks for explaining why it got stopped, using that as useful information for other people who have drafts that stop and then maybe can get resurrected again. So I think that was a useful and informative lesson, and thanks for your honesty.
Thank you, Yumi. Then to translate. Chris Patton.
Yeah, I just noticed that the BBS signatures draft is like makes an informative reference to this draft. So I think it's important for us to revive it in any case.
Yes.
So that, test vectors are based on something that we've written down.
Yep, and we'll be hearing about another document that depends on this up next.
Hello, can you hear me?
We can hear you, John.
Great. So this is, I guess, the day after Halloween is kind of appropriate for these drafts in that they're returning from the dead. I had a conversation about 2 weeks ago now with Dan Bonet, where we were discussing BBS and potential zero knowledge schemes like Longfellow, et cetera, and how we're working towards having these in production in digital credentials and the sorts of things that are depending on it. And I made the mistake of referring to BLS signatures or not referring to BLS signatures as traditional cryptography because to my mind, the spec wasn't done, and to Dan's mind, it was done so long ago. What are you talking about? As near as I can make out, and I've been asked by a number of folks, people may know me from the Jose working group, where JSON web proofs are being worked on. So a number of folks, including some of the chairs, and Dan is one of the original authors, has sort of put me up to moving this forward. Do I advance the slide or do you? Okay. So
either way.
We've agreed to resuscitate the spec because we have a lot of stuff that's dependent on it. So I have uploaded a new version with a new reference on faster subgroup checks for the BLS 12 381 curve. Added myself as a new author so that I can actually do some of the editing on this. So that's pretty much it since the 2022 last draft, which was in 2022. Next slide. So some of the motivating material behind this is that we have the European Union, which is exploring BBS as a privacy and scalability solution for EIDAS. That is to some extent competing with Google's Longfellow approach and others. Anya is working on it on the BBS side from the German government. So we have a lot of activity. There are some new papers around how to do holder binding so that we can move this out. We have a backlog of specs in CFRG that have this as a dependency, and specs in Jose that have these other CFRG specs as dependencies. If we can move on. Some of the other stuff that's going on is NIST has a multi-party threshold cryptography call workshop coming up, I believe, actually next week. If that actually happens, which is, I believe, significantly in question. there are at least two groups that we know of that are making proposals to that based on BLS signatures. So there's more work. People had sort of assumed that BLS signatures was a done deal, but never actually made its way through the finished making its way through the CFRG before people got distracted by other things. To talk to the chairs, maybe one way of progressing this stack of specs is to organize an interim meeting where we can focus on the BLS curves, BLS signatures, and all of the things that depend on it, so that we can try and progress them as a package, so that some of these other areas of interest can be worked on. And that's I'll stop there and take questions to my limited ability.
All right, any queued up questions? And feel free to ask questions or come up with statements at the mic regarding this entire dependency stack of documents that we're working on. For example, there were, as Yumi described in the pairing-friendly draft, there were some comments about wanting it to be more descriptive on the algorithm side rather than just listing out parameters. This is a long time ago that this discussion happened. So if anyone has opinions about this now and is willing to share them on the list or at the mic, please do. And right, we've got Michael Jones.
Mike Jones, I'm at the top of this stack of dependencies, being an editor of the JSON Web Proofs draft in Jose, which depends upon BBS signatures, which depends upon BLS signatures and pairing-friendly curves. I really want to see all this stuff finish so that Dan Benet's belief that this is finished cryptography becomes true in practice. Yumi, I'll talk to you about key representations. I just am updating the key representation draft right now, but we'll take that offline. Thank you.
Hello.
Michele, you have to get in. Did you get in the queue?
Oh, sorry. Online?
On the Meet Echo. It's all right. You can speak at the mic. We know who you are. No.
Hello. So sorry. Yeah, Michele, editor, I think, of the FIA and Sigma protocols, interactive Sigma protocols internet draft. I wanted to ask, but also more in general to the community. We right now have like a number of drafts, like the BBS draft, hash to curve, ristretto, and the pairing curves that all talk about elliptic curves, but there is no unified interface. And this is becoming a problem because we have like misalignment between different drafts. And as we move forward also with post-quantum or hash-based zero-knowledge proof, we will also need a definition of field. And so maybe the thoughts, your thoughts on like, how do we get to this common interface, or more in general, the community, if the CFRG should enforce a single definition, that would be really appreciated for us to move forward.
Okay. Any? That was Michele Oru. He's the presenter of the first one on Thursday, so you can spell his name in the agenda. So the question was about whether or not CFRG should look at writing a document about the interface towards elliptic curves and interacting with it. Okay.
So I just wanted to comment. I think there is like a boilerplate API that has emerged over many drafts for like prime order groups, and I think it's probably not perfect, but this is kind of the de facto standard. I think it would be fine to have a draft that kind of defines it, like kind of lays it down, but I think it'll be something that people break with from time to time. I think it's hard to get it perfect, even though it's elliptic curves and we should be moving on from elliptic curves anyway. But yeah, anyway, yeah, I think it's just not strictly true that we don't. I mean, yeah, I guess it has. Yeah, it's true that's not standardized. Yeah, but like, I guess one question for Michele is should it be prime order groups or should it be elliptic curves? And is there a meaningful difference in your mind?
No, I think it should be fields, then elliptic curves, then pairing-friendly elliptic curves. And
Cool.
if you break any of that, we are breaking up like compatibility with things in the future. And another standard that is not necessarily compatible with what's been done in hashing to the group is the ristretto RFC that is not doing exactly what's in the hash to the group spec.
Yeah, that was discussed actually during the writing of that draft, and the authors chose to go their own way. Any other thoughts or questions about this? We do have some extra time because Armando wasn't able to present today. So any other thoughts or concerns here? Also, if there's anybody who wants to volunteer to help flesh out the pairing-friendly curves draft, I know no one had stated an opinion at the microphone whether simply giving parameters would be sufficient for this project versus a full explanation. But that was the feedback on the draft from the last call. So that's something that we need to resolve and get consensus for, and we can do so on the list.
I'll just say that I think parameters are sufficient.
Pardon me?
Just parameters would be sufficient.
Just parameters would be sufficient. Okay. There was a suggestion by John that we would put together an interim. We had a successful interim for. Oh, we have a few more folks in the line, but an interim is definitely on the table. Let's say, Hannes.
Yeah, since you asked the question, I posted my view in the chat. But often it's very helpful for developers to also have a little bit of context. So I think it's a little bit black and white to just talk about parameters only versus a full-blown, almost like textbook tutorial. But in general, like there's always a description, specifically with some of the cryptographic material that gives developers insight into what they should do, how they select certain parameters, and so on.
Brent Zundell, I think parameters are sufficient.
Okay. All right. Any other business? We're doing late agenda bashing due to mispresentation. Okay. Well, we'll end it early this time, and we'll have a very packed session on Thursday. Hope to see you then. Goodbye from me, Alexei, and Stanislav, who's on the chat.
Thank you. Bye.
No, but I'm happy to make it. Yeah. Oh, nice. Yeah.